Okay, so in this video, we will be looking at the chain rule. This will be our last rule of differentiation. And the chain rule tells you how the derivative behaves over a composition of functions. So here's the result. The derivative with respect to x of the composition f of g of x is equal to. And now the chain rule is a recursive rule of differentiation. And the way to think about it is like peeling an onion. We start with the outer layer and we work our way towards the inside. So if you think of this here, we have f of g of x. So the outer function is f. So the chain rule says first differentiate the outside function. So f prime. And you take f prime, the derivative of the outside function, at g of x. That's the first step. And now, once that's completed, you forget the original function, the outside function. So you've just peeled the first layer off of your onion, times, and now you repeat, times the derivative of what's left over. Well, what's left over is g of x, so times the derivative, g prime, of x. And that's the chain rule. So always think of it as you differentiate the outside function and you work your way towards the inside, one derivative at a time. Let's do an example. What if we ask for the derivative with respect to x of the function, say 3x minus 2 to the power of 10? Now the question is here, well, what's f, what's g? Always think of f as being the outside function. And how do you find the outside function? Well, think about it this way. If you were to evaluate the expression for a given value of x, what is the last thing you would compute? Suppose I give you here x equals 4. Well, you would do first 3 times 4, then you would subtract 2, and finally you would take the 10th power. So the power of 10 here is the outside function, the last thing you would compute. And that's your f. So the chain rule says first differentiate the outside function. Here it's the power of 10, so we use the power rule, which says bring the exponent down and subtract 1 to the exponent. 10 minus 1 is 9. And now that's the derivative of the power 10. That's gone. And it's the derivative of the outside function evaluated at the argument. Well, here the argument is 3x minus 2. And that's the first step. That's the derivative of the outside function evaluated at the argument. And the chain rule says quite simply, multiply what you have so far by the derivative of the inside, whatever is left over. So we took the derivative here of the outside function, power of 10, that's gone, and we multiply what we have so far by the derivative of what's left over. The derivative of 3x minus 2 is simply 3. And we can write, finally, 3 times 10 is 30. So all we have is 30 times 3x minus 2 to the 9th power. And there you have it, the derivative of this function. What about this example? The derivative with respect to x of, let's now take a quadratic. So x squared minus 2x plus 9. Let's take the 4th power. Once again, the power is the outer function. If I gave you a value of x, you would first square it, subtract 2 of x plus 9, and then you would take the 4th power. So the outside function is the 4th power. Once again, we use the power rule, bring the power down, subtract 1 to the exponent, you get 4 minus 1 is 3, and it is the derivative of the outside function at the inside function, which is x squared, minus 2x plus 9. That takes care of the outside function times the derivative of the inside function. And the derivative here is the derivative of x squared, 2x, minus the derivative of 2x, which is negative 2, plus the derivative of 9, which is 0. And that takes care of what's left over. There is nothing left over, so we're done with the differentiation. Here, we can factor a 2 here and have an 8. 2 times 4 is 8. If we factor 2, we're left with x minus 1, so it's 8x minus 1, times the cube of our quadratic. So x squared minus 2x plus 9, all cubed. What if we had, say, a cube root? So the derivative of the cube root of 6x plus 1. Well, the question is always, what is the last thing we would compute if we try to evaluate the expression? What is the outside function? If I give you a value of x, you would do first 6 times x, then you would add 1, then you would take the cube root. So the cube root is the outside function. But before we differentiate it, let's recall that the cube root is just the power of 1/3. 1/3 is the outside function. We differentiate with the power rule, bring the exponent down, subtract 1 to the exponent. A third minus 1 is negative 2/3. Add the inside function, so 6x plus 1, and that takes care of the derivative of the outside function, times the derivative of the inside function, whatever is left over, and the derivative of 6x plus 1 is just 6. And now there's nothing left over, so we're done with the derivative. And 6 times a third is just 2, so it's 2 times 6x plus 1 to the negative 2/3. Now, the question is, what if we have not just a single composition, but two compositions? Then how does it work? And the answer is exactly the same. You peel off one function at a time, always working from the outside function towards the inside function. Let's look at this example. The derivative with respect to x. Let's take x minus 4 cubed minus x squared all to the 5th power. Well, again, think of it as if you were to evaluate this function, what would you compute first? Well, if I gave you x, you would do x minus 4, then cube it, then minus x squared, and once you have all this, you would take the 5th power. So the power of 5 is the outside function. The chain rule says differentiate the outside function. Bring the 4 down, the 5 down, subtract 1 from the exponent, and that's the outside function. Add the inside function, x minus 4 cubed minus x squared. So that's the first step. There's still something left over. The chain rule says times the derivative of what's left over. Well, let's now differentiate this. It will be the derivative of this function minus the derivative of this function. Well, once again here, we have to use the chain rule. We have x minus 4 all cubed. So if I gave you x, you would first do x minus 4, then cube it. So we must use the chain rule on the first function. So we use the power rule, bring the exponent down. That takes care of the 3 times the derivative of x minus 4, and that's just equal to 1. So that takes care of the first function, minus the derivative of x squared, which is simply 2x. And now there's nothing left over, and we have found the derivative. We could, if we wanted to here, simplify by squaring this, multiply by 3 and subtracting negative 2x, and then see if we can factor it, but that's just algebra. I'll leave it up to you. And now we have the derivative. Let's look at this example. So what if we asked for the derivative of, say, 2x minus 1 over, let's say, 3x plus 4 to the power of 1/3? Well, we have a composition. What is the outside function? Again, think of it as if I give you value of x and you evaluate the function, what is the last thing you would compute? Well, you would do first 2 times x minus 1, then divide by 3x plus 4, and then you would take the cube root, the power of 1/3. So the outside function is 1/3. We use the power rule, bring the exponent down, subtract from the exponent. 1/3 minus 1 is negative 2/3. And it is the derivative of the outside function at what's inside, 2x minus 1 over 3x plus 4. But there's still something left over. So the chain rule says we have to multiply what we have so far by the derivative of what's left over, which is the fraction 2x minus 1 over 3x plus 4. And now the derivative of what's left over, and there's nothing left over, so we're done. But we have to find this one now. Well, we have a quotient, so we now have to use the quotient rule. This stays there. 1/3 2x minus 1 over 3x plus 4 to the negative 2/3 times the derivative of our quotient. So we call the quotient rule. We'll have the derivative of the top, which is simply 2, times the denominator, 3x plus 4, minus, and now we flip, right? The numerator, 2x minus 1, times the derivative of the denominator, which is 3, all over the denominator all squared. So 3x plus 4 all squared. And now we're done with the differentiation. So you see, in one problem we had to use the chain rule times the derivative of what was left over. And since we had the quotient, we had to use then the quotient rule. Let's now do the algebra. Let's simplify the expression a little bit. We can multiply our numerator and regroup the multiples of x and the constant terms. So we have 1/3 2x minus 1 over 3x plus 4 to the negative 2/3 times. Well, 2 times this will give us 6x plus 8 minus 2x times 3 minus 6x. Negative 1 is positive 1 times 3, positive 3. Over 3x plus 4 squared. So what happens on top? Well, the 6x minus 6x cancels, and we're left with 8 plus 3, 11. And if you notice here, there's another term of 3x plus 4, and let's split those two up, and then we'll regroup similar terms. So what does that give us? Well, 1/3 2x minus 1 to the negative 2/3 3x plus 4 to the negative 2/3 times 11 over 3x plus 4 squared. And now let's combine. We'll have, if we put the 11 over 3 up front as a constant multiple, we'll have 11 over 3 times 2x minus 1 to the negative 2/3 over, and if we multiply the same term, you add the exponents, right? So we'll have 2 So it's going to be 3x plus 4 to the power of 2 plus negative 2/3. Well, 2 is 6 over 3. And 6 over 3 minus 2 over 3 is 4 over 3. And here, there's one last thing we could do. If you prefer to have positive exponents, we could send this to the denominator. And what we would then get is a single 11 on top over 3 times. The 11 stays on top. The 3. 3x plus 4 to the 4/3. And if we send this term down, the negative 2/3 becomes a positive 2/3. So 2x minus 1 to the positive 2 over 3. And that's our derivative. So the derivative of the cube root of 2x minus 1 over 3x plus 4 is 11 over 3, 3x plus 4 to the 4/3, 2x minus 1 to the 2/3. And there you have it. Let's do an example now where we have to use the chain rule and the product rule all in the same problem. So this will be our last example. So here's the problem. Let's ask for the derivative, so d over dx. And here's our function. We'll take the 10th power of 6x plus 1 times the 6th power of x squared minus 3x plus 4. So right away here we have to find the derivative of this product, so we have to use the product rule. So this is the first function. This is the second function. And if you remember, the product rule says all you need is a derivative of the two individual functions. If you call this f of x, and you call this g of x, the product rule says that this will be the derivative of the first function times the second function, plus, and now we flip the role of the derivative, so plus the first function times the derivative of the second, the derivative of the first times the second, plus the first function times the derivative of the second. So all we need now is the derivative of f and the derivative of g. So let's find both of these separately, and then we'll plug them in. So f prime of x is the derivative of the function 6x plus 1 to the 10th power. And now here we have a composition. We have to take or use the chain rule. So if I give you x and you plug it in here, you first do 6 times x, then add 1, and then you take the 10th power. The outside function is the power 10. We differentiate the outside function with the power rule, and we evaluate at whatever is left over, 6x plus 1. And the chain rule says you have to multiply what you have so far by the derivative of whatever function is left over. We're left over with 6x plus 1. The derivative of this is 6. And now there's nothing left over, so we're done with the differentiation. Let's differentiate g of x. So g prime of x is the derivative of x squared minus 3x plus 4 all to the 6th power. Once again, here we have a composition. If I give you a value of x, you first square it, subtract 3x plus 4, and then take the 6th power. The outside function is the 6th power. We use the power rule, and we evaluate the derivative of the outside function at what's left over, x squared minus 3x plus 4, times the derivative of what's left over, this quadratic. The derivative is 2x minus 3 plus 0, and now there's nothing left over. So we have our f prime of x and we have our g prime of x. And now we can replace in the expression. So the derivative of this function times this function, and now the rest is algebra, right? We found the derivative of both f and g using the chain rule. That's a matter of plugging it in and simplifying as much as we can. So f prime of x, we'll write 10 times 6 times 6x plus 1 to the 9th power. That's f prime of x times g of x. X squared minus 3x plus 4 to the 6th power. Plus f of x, 6x plus 1 to the 10, times now the derivative of g of x, which is 6. I'll put this term first, times 2x minus 3, times the 5th power of our quadratic, x squared minus 3x plus 4 to the 5th power. And now here we have a sum of two terms. Let's go up, right? G prime, 6 times 2x minus 3 times x squared minus 3x plus 4 to the 5th power. And now we're done with the differentiation. The rest is algebra. And again, when you want to simplify a sum of two completely factored expressions, you pull out as many common factors as you can. Well, if you look, there's a 6 here and a 6 here. So we can factor that out. We take it away. What else can we factor out? There's 6 plus 1 to the 9. There's 6 plus 1 to the 10. So we can factor 9 of them. So 6x plus 1 to the 9. If we factor 9 from all 9, we're left with nothing. If we factor 9 from the 10th term, right, we have 10 here, factors of 6x plus 1. We take away 9, we're left with only 1. What else can we factor? Well, we have here this quadratic. There's 5 of those here, 6 here. So we can factor 5. So x squared minus 3x plus 4 to the 5th power. If there are 5 here and we take away all 5, there's nothing left for this quadratic. And if there are 6 and we took away 5, that leaves us with only 1. And if you look at what's left over, there are no more common factors. There's a single 10. There's no constant term here. There's the quadratic, and it's not here. So now we've factored all we could. And we're left with the two leftover terms. 10 times the quadratic plus 6x plus 1 times 2x minus 3. And what's left now is simply to multiply both of these expressions and pair up the multiples of x squared, x, and the constant terms. Let's do so. So we recopy what we have here. So 6x plus 1 to the 9, x squared minus 3x plus 4 to the 5th power, times. Let's multiply. So 10 times all this gives us 10x squared minus 30x plus 40 plus 6x times 2x is 12x squared. 6x times negative 3 is negative 18. Positive 2x, that gives us negative 16x. Plus 1 times negative 3, negative 3. And now we can simplify. Multiples of x squared. There's 10x squared plus 12x squared. That's 22x squared. Multiples of x, negative 30x, negative 16x. That's negative 46x. And the constant terms, positive 40 minus 3, negative 37. And there you have it. The derivative of this function, with the help of the chain rule for the derivative of both f and g individually, and then the product rule, gives us this as our final answer. And you see the leftover quadratic, if this happens to be the case, if you have a quadratic term, if you can factor it easily, you should factor it. But something like this, you're looking at this and you say, it won't be clear how to factor it. Just leave it like this, and that's no problem. So this is the chain rule.